Okay, Naveed, let's proceed ahead with your technical snap for strength of material. And
Yes, sir.
you will tell me, the different type of stresses which are induced in the material.
So we have sir tensile stresses, compressive stresses, and shear stresses are there, and bending stresses also. But bending
That's it.
stresses, they are a type of tensile and compressive only.
Mm-hmm.
So
These
mainly
are
tensile, compressive, and shear.
any other type of stresses which you are aware?
Uh,
Okay, tell me type of shear stresses.
so type of shear stresses.
Mm-hmm.
So we have torsional
Okay,
stress.
what are the different ways in which you can induce shear stress in a body?
So by one is by applying torque
That is
and
called torsional shear stress, right?
torsional shear stress.
Okay, what else?
Another way is for a beam we can apply load in the transverse direction. So for a particular cross section, this will be in the longitudinal direction. So this will
To
also
take a bar and apply normal force on that. Can it
yes sir.
induce shear stress in the bar?
Yes sir, it will induce on different planes. We will have different oblique planes and shear stress will be induced.
Which plane it will induce maximum shear stress?
So I will try to draw its Mohr circle.
Not even required. You can answer me otherwise. Just think and tell me.
So so I think it will be for 45-degree plane.
You know what is
Shear.
chalk used to write on the board? You know
Yes
that?
sir. Yes sir.
If I apply torque on the chalk,
Yes
at
sir.
which plane it will fail?
So chalk is a brittle material.
Yes.
So that will fail. So I will try to draw its Mohr circle first.
No, that is not required. You
So
can
not required.
otherwise answer. Yeah, it's not required actually to draw. You can answer it otherwise.
Uh, Sir, I think along 45-degree plane.
Why is that then?
So because for that plane, is shear stresses will be maximum.
Okay, and brittle material fail in shear stresses.
Also ductile materials fail in shear stresses.
So this is the brittle
Brittle
material.
material fail in tensile load.
So why it fails in shear plane then?
So that's why I was trying to draw more circle. It will be
Okay,
more
draw it.
easier.
Okay, draw it.
So we are applying shear stress.
Okay.
Uh, so I think it will fail perpendicular to the axis.
Perpendicular to the axis. That means 0 degree.
0 degree.
You sure about that? Okay, just use your brain and tell me if I give you a chalk and you apply normal force on that, pulling, how does it fail? ये तो तुमने स्कूल में देखा होगा. एक चौक लिया जिसको ऐसे खींचा मैंने, आई पुल्ड इट,
Yes sir.
कैसे फेल होता है?
So I think perpendicular to the axis
हाँ,
only.
परपेंडिकुलर पे फेल होता है नॉर्मल फोर्स लगाने पे.
Yes sir.
नाउ आई एम नॉट अप्लाइंग नॉर्मल स्ट्रेस, नॉर्मल फोर्स, आई एम अप्लाइंग टॉर्क.
Torque.
तो उसी प्लेन पे तो फेल नहीं हो सकता, क्योंकि नो आई एम नॉट अप्लाइंग नॉर्मल स्ट्रेस, आई एम अप्लाइंग द शियर स्ट्रेस नाउ. Okay, let me ask you a question. When you apply torque on the chalk, which is the
Yes.
principal plane? Where is the principal plane?
When we apply torque.
On a chalk, where do you get principal plane?
Sir, at which the tensile stress will be either, the normal stress will be either maximum or minimum.
So where is normal stress maximum if I apply torque on a chalk?
Sir, it will be on the 0 degree plane.
And if I apply normal stress, then where will be the principal plane?
If we are applying normal stress,
Just apply sigma x and tell me where is a normal plane. This is a principal plane.
sir, in that case also it will be along the 0 degree plane.
So whether you apply normal stress or you apply shear stress, the plane will remain, principal plane will remain same. Is that what you're saying, Navid? Okay, tell me what is the significance of drawing Mohr circle? Why
Sir,
do we do it?
so Mohr circle is basically graphical representation of normal stresses and shear stress on various planes. So by just looking at the Mohr circle, we can tell at different planes what will be the value of shear stresses and normal stresses induced.
Mhm. Mm. Okay. Okay, Navid, let me give you the feedback of this part. Navid, you
Yes, sir.
still need to revise.
Yes, sir.
When you apply normal stress, 0 degree and 90 degree are principal plane. When you apply shear stress, then 45 degrees is the principal stress. That is the principal plane. Brittle material fails on principal plane.
Yes, sir.
Ductile fail on plane of maximum shear.
Plane of maximum shear.
The chalk, if you apply normal force on chalk, normal stress is 0 degree. It will fail from the middle.
Yes, sir.
If you apply torque on the chalk, now principal plane is 45 degree. And
Yes,
since
sir.
it's a brittle and fail on principal plane, so it will fail at 45 degree. It was a simple question, but you got confused in this, right?
Yes, sir. I got confused actually.
So what is
I
to be
have to
done
revise
with that?
it.
Now, what is the solution? Though you have knowledge base, but he will make you confused, right? They have the knowledge, so they can easily make you confused. So what you have to do is you have to revise that marathon again and again.
Yes,
That's
sir.
the mantra.
Revision is must.
Yes, revision is very, very important. I mean, the marathons which we have produced, like 8 hours marathon, you have to see it at 1.5 speed.
Mm-hmm.
And you have to see it 3 times minimum. That is what is
Yes, sir.
required. And you know, every time when you see it, you will get something new.
Yes, sir.
And
Yes, sir.
then after seeing it, you have to go for snaps of strength of material, something like this. I'm asking you a question. Now this will be saved in your PDF panel.
Yes,
And
sir.
you will have hundreds and thousands of such snaps. Your teacher is asking a question and student is giving the answer. Right? So that is for your self practice. And then once you say, okay, now I'm ready. Let's go to sir now. Let's go to the teacher. Let him ball. I'm gonna bat. But the way you have come for this level was little less. Though it is helpful because we make you realize that you need to prepare.
Yes, sir.
Yes, that is how Navid you have to follow the entire.